Study on control consists of grid connected solar photovoltaic plant based on simulation. Along with the advance of renewable energy development strategy, photovoltaic power technology has gained rapid progress in recent years, and due to the rapid growth of the PV power penetration in power system and research with the PV power grid integration are drawing more and more attention, such as low voltage ride through LVRT, automatic voltage control (ABC), voltage stability, and so on. This paper investigates on the voltage and reactive power control characteristics of the grid-connected solar power plant based on simulation. The voltage and reactive power control strategy used in grid-connected inverter and static VAR compensation drive a flexible and controllable source of reactive power to regulate the voltage and reactive power of large-scale PV power plant. The PV inverter and SVC both have variety of control mode generally, such as constant voltage control mode, constant reactive power control mode, constant power factor mode, control mode, and so on. The coordination control of characteristics between the PV inverter and SVC is analyzed in this paper, and through in depth study of the characteristics of different combination of control mode, the operation characteristics of PV power plant are summarized. The research results of this paper are helpful to development of ABC automatic voltage control system. According to the introduction, the law of photovoltaic plant operating characteristics are very important for plant operator and grid operator. In particular, power plant built with variety of power dynamics built with variety of power electronics equipment, and the operating characteristics have become very complex. It is necessary to study the law of mean simulation tools. This paper focused on the study of photovoltaic inverter and SVC. Firstly, the photovoltaic inverter and SVC are detailed modeled. Then it considered the characteristics of the photovoltaic inverter and SVC in constant voltage control mode. The constant reactive power control mode. Through the stimulation of the simulation environment, we can deeply research on coordination law between the various control modes. For example, by means of simulation tool, we can rapidly develop AVC control system and test the system performance. Dynamic model description. In dynamic model description, we can see the principle of time domain simulation method. The principle of time domain simulation method. This paper assumes that the analysis is mainly focused on the how the control strategy of the photovoltaic plant react to the grid disturbance, fault on the transmission system, and details of the device dynamic have been substantially simplified. The model are for positive sequence time domain simulation, especially the very fast dynamic association with the control of the inverter. Control of the converter have been modeled as algebraic. The dynamic model of photovoltaic system is realized based on the implicit trapezoidal integration method. The current is injected into the sequence network by the coordination transformation, and different algebraic equation integration is performed. So based on the implicit trapezoidal integration method, we can dynamic model of the photovoltaic system, coordination transformation, and positive sequence component complex sequence network, and this is negative sequence component Z naught is zero sequence network, negative sequence negative component, and positive sequence component. And differential algebraic and differential integration, we can apply zero sequence network, zero sequence component, and negative sequence component. That this is connected to the grid. PV model. The dynamic model and the operating characteristics of the photovoltaic system has been researched more in recent years. For example, WECC, Renewable Energy Study Group, established two generic photovoltaic power generation system, positive sequence dynamic model and GE has issued stability analysis model of its series of photovoltaic module, photovoltaic product, and the model has been released in PSLA software. This model has been widely studied and used. The section analysis of structure of GE model of photovoltaic system. The overview structure of the model is shown in figure. There is a control model. This is control model, and IP and IQ are active power command and reactive power command. This is converter, and converter connected to the generation, active power generation and reactive power generation, then trip circuit, and then connected to the grid. So this is solar power model for power order. The interface between photovoltaic system and network may be current source structure or voltage source structure. The interface of GUI model in current source structure. The current source structure is used in this paper, and the structure is shown in the figure. Then the current source structure is IED reference and IQ reference, cos reference and sin reference. According to that, we can apply to the grid and V term voltage connected to the transformer. The interface between PV system and the network. The interface between photovoltaic system and the network use the positive sequence current and D-axis reference, positive sequence current D-axis reference, and positive sequence current Q-axis reference to drive the current source. The terminal voltage of photovoltaic system is input parameter of the control system for constant reactive power control mode and constant voltage power control mode. The positive sequence control model dictate the active power to the delivered to the system based on the power flow initial condition. It contains two main parts, the electrical control part and the solar control emulation part. The detailed representation of the electrical control is shown in the figure. This model simplifies representation of the converter control system. So there we can control and Q generation compared this V maximum and V minimum, and there is V reference generate, and after that IQ current is also generated, IQ maximum and IQ minimum, and then IQ control signal is generated, then current converter current limit, PQ priority flag. This solar control emulator function represents a simplified equivalent of the supervisory reactive power control portion of the entire photovoltaic plant. Management system, a detailed representation of reactive power control is shown in the figure. Reactive power control. So this is the detailed representation of reactive power control we reference here, and Q reactive power, active power, Q minimum, Q maximum, and Q in order, and this is used for integration. A model of SVC, static reactive power compensation, makes the use of thyristor control reactor and different static switch capacitor and reactor so that it can absorb and emit the reactive current capacity for improving the power factor and the stability of system. So inhibit the system oscillation. The primarily SVC shown in the figure. This is SVC. The model of SVC type 1, which is provided by the PSASP software, is constant voltage control mode. The diagram of SVC type A first is shown in the figure, and this is a comprehensive amplification. This is measurement. We can apply comprehensive amplification and apply to the control. After that, we can apply to TCR, and after that, connected to the grid. The model diagram of SVC type 1 constant voltage control mode. In development of photovoltaic plant, automatic control as AGC and automatic voltage control. We need to model the provide the constant reactive power control mode with aim to meeting the reactive power control target. The method of change the feedback system. The method of change the feedback signal from the bus voltage SVC reactive power in order to achieve no differential regulation. It replaces the comprehensive amplification block, which is inertia block, with PI block. The diagram of the SVC and constant reactive power control is shown in the figure, and comprehensive application is compared to the PI block. The model diagram of SVC type constant reactive power control. So this is used for constant reactive power control. Next, control strategy simulation. The model is described in this paper has been implemented in a dynamic simulation software. In order to study the control strategy, a model of power plant is built by using the models above according to the parameter of practical Voltaic plant. The control parameter of PV plant and SPC is simulated. And grid standardized simulation 10 megawatt solar photovoltaic plant is configured with the minimum number of converters 0.9 power factor at the terminal bus. It is equivalent to rating of the 10.1 mega MVA and reactive capacity of 4.7 MVA. Next, this is the test system of our test system. Terminal bus solar term, PV and transformer, solar grid. Power flow calculation. When all photovoltaic inverters are in rated power, the power flow chart and voltage distribution are obtained by the power flow calculation. And grid voltage and photovoltaic H and photovoltaic L, voltage magnitude, phase angle, power grid, Q, PG, active power, reactive power, and PI, megawatt power. The power plant constant reactive power control mode only. The photovoltaic plant generates reactive power according to the certain instruction from ABC, which is shown in the figure. And because the reactive power capacity of photovoltaic power plant has limit 4.7 megawatt, we can see the reactive power limit is reached 14 seconds to 60 seconds. This feature can simulate the photovoltaic power plant reactive capacity configuration. We can see that the voltage of terminal bus and POI can be changed by photovoltaic plant reactive power command, and this is reactive power generation in MVAR and reactive power generation by the plant, and this is the voltage terminal bus POI and infinite bus. And when SPC equipped operation is according with the constant reactive power control, it generates reactive power that is given by this before. And compared to 10 figure and 1012, we can see that the reactive power generated by SPC and photovoltaic plant have the opposite trends. Therefore, the total reactive power is smooth. The voltage of POI are shown in the figure, and we can see the fluctuation of suppressed by SPC. And this is the fluctuation of SPC, terminal versus PI and infinite bus. SPC is planned to generate reactive power, which is shown in the figure. We can see that there is a delay between the reactive power generated by SPC and reactive power command. So there is a delay. And the voltage of POI has shown in the figure. It's shown that the bus voltage can be changed by SPC reactive power command. And when the photovoltaic plant operating in accordance with the constant power control mode, it generates reactive power. So next, the voltage of terminal bus and PUI are shown in the figure. We can see the voltage of fluctuation is suppressed by SPC. Comparing to figure 11 and figure 17, we can see that the effect of suppression of voltage fluctuation is poor relatively in their case. Through further analysis, we can see that the time of constant and voltage system of PV inverter is relatively larger than the time constant in control system of SPC. Therefore, SPC has better ability to inhibit the voltage fluctuation. And in conclusion, the article established in grid-connected solar photovoltaic plant model with the detailed model of SPC. Through power plant level modeling, we can evaluate the power control performance of the photovoltaic system with the SPC installed. It can simulate constant reactive power control mode and constant voltage control mode and so on. By means of the simulation tool, we can rapidly develop the ABC control system and can also provide basic experience of the scheduling and grid operation department. According to acknowledgement, the work is supported by key laboratory of grid connected photovoltaic technology in Qinghai province, 2014, and research program for youth of China, Electric Power Research Institute.